1 from our textbook, Understanding Quantities and Their Relationships. Guys, I'm going to be skipping around a little bit, but 2 things that I need for you to know: dependent quantity and independent quantity. Dependent depends on something. Independent is in control. On a graph, our dependent quantity is always your y value, and your independent quantity is always your x value. So you have your independent and you have your dependent. So when you're looking at a graph, you're going to know that, okay? We've got some scenarios here. I'm just going to talk about a couple of them so that you can kind of see how this works. So here's the first one. Have you ever planned a birthday party? You may have purchased ice, gone grocery shopping, selected music, made food, or even cleaned in preparation. Many times, these tasks depend on other tasks being done first. For example, you're not going to make the food before you go grocery shopping. In addition, I'm probably not going to purchase the groceries until I know who's coming. So we're going to look at some dependent and independent quantities down below. In our directions, they ask us to circle the independent quantity and underline the dependent quantity. So I want you to think about independent. Which one is in control? Which one determines the other one? If I'm going to go to the movies with friends and I know that I've got movie tickets that I'm going to purchase and I want to know the total cost. In this one, which one would you need to know first to figure out the other one? We would need to know how many tickets am I going to buy before I can figure out the total cost. So this is your independent or your X. This is your dependent or your Y. In the next scenario, I have eggs that are going to be used to bake cakes. Well, if I know that I need 5 cakes, I probably need to know the number of cakes that I need before I go to the store and buy the eggs to bake those cakes. So the number of cakes that I need is independent, and it will help me figure out the dependent Y, how many eggs it's going to take. I'm not going to go through all of these, but you get the idea about independent versus dependent. Now we're going to look at some scenarios, and we are going to try to figure out which graph matches each scenario. So here's my first scenario. Natalie is going to buy some songs. When she buys her songs from the online music store, she's going to pay $1 per song. So I want you to think about what's being measured here. Clearly, we're measuring songs and we're measuring money. So how many songs I buy, is that going to determine how much I'm spending? Or is how much I'm spending going to determine the amount of songs that I buy? Well, I think most of us would go ahead and decide how many songs we're going to buy. And then that would tell us how much we're going to spend in dollars. If I was going to graph this, songs and then dollars, okay? And if I go buy one song and I pay $1, think about this. X is my songs, Y is my dollars. Okay, so if I buy one song, it costs me $1. If I buy 2 songs, it costs me $2. If I buy 3 songs, that costs me $3. So you can see that it's going up at a constant rate. We know that as a linear relationship. And I'm actually going to pull up a screen of the second page. Let me find it real quick. Here it is. A second page that we're referring to. These are 6 graphs, and one of those matches this situation. Now, as the number of songs increases, so does the amount of money that I'm spending. What if I buy 0 songs? How many dollars would that be? That would be $0, right? Okay, graph E shows a linear relationship. Songs, dollars. Spend $1, 1 song. $2, 2 songs. So this is actually graph E matches this scenario. And this is also in the workbook, I believe, on page 15. Okay, here's my second scenario. Something's fishy. Kaya is a building manager for an office building. We have an aquarium. It's got 200 gallons in it. To clean it, we have to remove the fish from the aquarium and drain the water. We're going to be draining at a constant rate, 10 gallons per minute. Guys, that's kind of an easy indicator that we have a linear relationship. Now, I want you to think about what's being measured here. The gallons of water and minutes is being measured. Well, what is in control here? Is the amount of time determine how much water gets out of the aquarium, or does the amount of water drained determine the amount of time that goes by? Well, it's really time. Time is almost always your X, your independent. So independent is the minute, the amount of time that I'm draining water from my aquarium. The dependent quantity is the gallons of water that are being drained. And I want you to think about this. If this is my minutes and this is my gallons, we are not starting at 0 gallons. We started with 200 gallons. We started when it's time of 0, we started with 200 gallons. And as time went by, it's less and less and less water because water is draining out of my aquarium. So that is going to be graph A. We've got, oh, I did not mean to put a G there. We have time and we have gallons. So that's graph A. Now, as you can see, we're going to go through some more scenarios and we have 4 graphs remaining. I want you to look at these graphs and see what's happening. In graph B, it looks like it's going up gradually and it keeps going on forever. In graph C, we're going to go down and then we're going to go up. Graph C, we're going down gradually. And in graph F, we're going up and then coming back down. So think about what's happening in each of these scenarios, and we're going to think about what's being measured. I have my eye on an upgraded smartphone. I currently don't have enough money. My cousin will provide the funding as long as I pay him back with interest. He tells me that I only need to pay $1 in interest initially, and the interest will double each week after that. So I'm going to just figure out if this is a good deal or not. Well, what's being measured in this problem? Clearly, money that I'm paying him back is being counted, but also we're counting weeks. Well, remember, weeks is time, and time is almost always your independent quantity. So the number of weeks is my independent, and my dependent is going to be the amount of interest that I owe. Now, I want you to think about what's happening here. If I was to sketch this graph, if weeks is down here and interest is here, this is my dollars, I start at 0 weeks. Over time, what's happening? I'm going to pay him a little bit more, and then I'm going to double that, and then I'm going to double that. So each additional week, the amount of money I'm having to give him is going up and up and up. Okay, that is going to be graph B. And I apologize, I should have put that this was graph A, and this other one, the songs one, was graph, I don't even see the letter on it, graph E. Oh, I did put that. Okay, next scenario. We have a magician who's practicing tricks. He is cutting ropes into pieces. He starts out with a 20-foot rope, and he cuts it in half. And so he's going to take each one of the halves and he's going to cut it in half again, okay? So what are we measuring here? We have rope and we have cuts. What is in control here? The number of cuts or the original length of the rope or the length of the rope? Well, when we cut it, we're making it shorter. So your number of cuts that's determining how long your rope is. And then I have my length of rope. Now, I want you to think about what's happening here. Cuts, length, because independent, dependent, but we do not start out at a length of 0. We start out at a length of 20. And after 1 cut, my rope is half as long. After 2 cuts, my rope is half as long as that. After 3 cuts, my rope is half as long as that. After 4 cuts, my rope is half as long as that. And it's getting to where you're really, really tiny. You're running out of room to kind of cut this thing in half. When you look at your pictures over here, it looks like that's going to be graph D. Graph D over here on the right side of the page is the one that looks most like that, okay? Baton twirling. I have a girl. She is throwing a baton in the air, and she's going to spin around and she's going to catch it. It says she is going to have 2 seconds to be able to turn around. And during that 2 seconds, that baton is going to go up into the air 22 feet, and then it's going to come back down. So remember I told you that time is almost always your independent quantity. So we're going to say our number of seconds is our our independent quantity. Did I say that backwards? Seconds is independent, and the feet in the air is going to be our dependent. It's going to go on our y-axis. Now, she's throwing the baton up and it's coming back down. So we either have the choice of graph C or graph F left. Well, which one of those looks like it's going up and then coming back down? Hopefully you can see that's graph F. Some of you might notice that the baton does not start out at 0, even though she's low and she's throwing it up. But you do need to realize my little twirler is standing with the baton in her hand. So the baton is not on the ground. She's up, she throws it up, it comes back down. Hopefully she's going to be over here to catch it in a minute. Okay, so that's graph F, which must mean I bet this last one is going to be graph C. We're going to go out on a limb and say that. We've got our skateboarder. He is on a 4-foot tall half pipe. He's going to skate down it, and then he wants to know how long it takes to get him back up. So you can kind of see this down and up motion going on here. Time, even though they don't mention it, time is going to be your independent quantity because it's how long is he skating, and then our dependent quantity is going to be the height that he's at. Not a great example, but we're going to go with it. Okay, so guys, when we're comparing this stuff, I want you to look at the graphs, and I want you to notice some similarities and differences. First of all, over here on the right-hand side, let me see if I can get my little pointer. Over here on the right-hand side, all of these, you've got some that are going down. You see that graph A is going down. Which graph most looks like it? Graph E. Those are both linear. One's going down, one's going up, but they are straight lines. And then you have two that have this curve. They kind of look like an L or a J. These two are gradually increasing or gradually decreasing, okay? And then you have this last kind, C and F. They're curved. One of them goes down and then up. The other one goes up and then goes down. That's not really what I want you to notice. What I do want you to notice is that all of these go from left to right, okay? And we're reading them from left to right. And if you'll think back to last year when you were in the 8th grade, we learned something called function or no function. All of these are actually considered functions, and we're going to talk in subsequent lessons about what we call the vertical line test, how it goes from left to right, and you don't have any X values that get repeated. So that's going to come up in later lessons. Independent quantities were almost always time. Some of them we had songs, but frequently time was going to be your independent quantity. The dependent quantity was frequently like the other thing that was being counted with time. The height, the number of feet long the rope was, the gallons of water. But usually time ends up being in a problem, okay? Let's see. I'm going to skip through this because this is not the most important part. And we're going to go all the way down to the activity. So I'm going to go back to full screen on this so we can go through our activities. And the big idea that I needed you to get out of this lesson is to be able to answer some questions. We're going to skip over these and we're going to go to the lesson 1 assignment. So I've got no, I'm sorry, we're not skipping that. I've got 4 scenarios and we're going to match each graph. So in the first one, I've got a local animal conservation organization is working with various reptile species. The initial population is 450 endangered turtles, and it gets tripled each year for the past 5 years. So remember we talked about time was frequently going to be our independent variable. So this would probably be our years. And this would be our population, would be the dependent variable. It doesn't start at 0, though. At year 0, we're not starting at 0. We're starting at a population of 450, and it's getting tripled And that's called an exponential function. It's getting big really, really fast, okay? So when I go look at these graphs, it looks to me like that's graph C. It's growing really, really quickly. It starts low, but it picks up really, really quickly, not at a constant rate. A constant rate would be lines. This is not a line, this is a curve. Here's B. Trung is playing video games at an arcade. We start with $40, and we're playing games that cost 50 cents per game, okay? What's being counted here? Games and money, right? Okay, which one's in control? Probably how many games we play is going to control how much money we walk away with. So our games is down here, money is here, and if you think about it, if it costs 50 cents, it's going down by 50 cents each time, and that is a constant rate, which means we will have a straight line. We are not starting with $0. We're starting somewhere up here at $40, and every time we play a game, 50 cents comes out of our pocket. Play another game, minus another 50 cents, minus another 50 cents. So I'm looking for a linear graph that's going down, and that's going to be graph B, okay? So B goes with B. Letter C. Eduardo works as a salesman. He gets a monthly salary of $3,000 plus 10% commission on the amount of sales. I don't know if you guys remember much about commissions, but basically whatever he sells, you multiply times 0.10, and that gets added to his salary, okay? So what's in control here? What he sells, okay? So his salary is determined by the dollars he sells. Now, the good news is he's going to start out with $3,000. But the more he sells, the more his money goes up. His salary is going to increase. So that is going to be a linear equation that's going up, and that's going to be graph A. So everybody see that graph A? So it starts out at 3,000 and it's going up 10% each time. This last one, anytime you see constant rates, guys, and I'm sorry, on the video games and on the salary, if it is going up at a constant rate or down at a constant rate, that is a straight line. This last one is a temperature, and it cools rapidly at first. Okay, once you think about cooling rapidly, that means it's moving fast, and then it slows down, okay? Remember we talked about time? This is involving time. So over time, the temperature is affected. We don't start out at 0 degrees. We start out way up at 180. And it starts dropping really, really fast, and then it slows down. And over time, it's not dropping as fast. So that's going to be graph D, okay? Now, we're going to compare these two graphs, and let's talk about similarities and differences. Similarities, well, they are both going up. If you're ever in question about is it going up or is it going down, we read graphs the same way we read books, from left to right. So if I write my name on this, Ms. Jones, and I write my name on this, Miss Jones, both of these are going up. So these are both increasing graphs. Neither one of them start at 0. You see how this one doesn't start at 0, and neither does this one, okay? So those are some similarities. Some differences, okay? One is linear, one is curved. That's a big difference. One starts higher than the other. So just whatever you can do to describe, okay? The last question here, can you identify some points and name the quadrants? First of all, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. To name a point, you always give the X first and then the Y. Where is it on X and where is it on Y? So for example, if I want to name point E, it is at 0 for X, and it is at, it looks like based on the scale, it must be skip counting by 2s because this is 4. This would have to be 2, so this must be 6. So it's at 0, 6, okay? If I want to know point D, I'm going to go look at point D now. Point D, On the x-axis, it's between the -4 and the -6. So point D would be at -5 for my x, and then it's going to be over at the 2 for the y, okay? I'm going to go do point C. Point C is right in between the 0 and the 2. So point C is at 1 for the x-axis. And when I follow it over to the y-axis, it's even with the -4. So that's just practicing ordering or labeling points. Okay, that's it for lesson 1.